I want to ask you to do something right now. Just wherever you are listening to this deep dive, I want you to look down at your
Yeah,
hands.
take a real look.
Right, and just feel the texture of whatever you are touching in this exact moment. I mean, maybe it is the steering wheel of your car or, a ceramic coffee mug, or maybe you're just feeling the heavy cotton fabric of your own clothes. Feel the weight of it in your palm, like the absolute unyielding solidity of it.
It feels completely real.
It really does. It feels like an undeniable physical fact. But what if I told you that everything you see, everything you feel, and literally everything you experience is not actually real in the way you think it is?
Which is a huge claim to make.
It's massive. What if the stars above us, the planets, the wood on your desk, and this entire sprawling universe are, like, nothing more than discrete lines of code running silently inside a massive, hyper-advanced supercomputer?
I mean, it is the kind of premise that completely shatters your baseline assumption of everyday life. We are conditioned from birth to trust our physical senses implicitly.
Right, exactly.
You drop your keys, they hit the floor, gravity pulls them down. It is a fundamental rule. But this deep dive is going to ask you to completely suspend that trust for the next few minutes. We are going to challenge the very bedrock of what you consider to be physical reality.
Okay, let's unpack this.
Yeah.
Because the mission of this deep dive is to explore one single, absolutely mind-bending text that takes this entire concept, the simulation hypothesis, and just yanks it violently out of the realm of science fiction.
Yeah, it really does.
Because for years, this was just late-night dorm room philosophy. It was a wildly entertaining thought experiment that tech billionaires love to talk about on talk shows.
Oh, definitely. The ultimate hypothetical.
Exactly.
Yeah.
But today, we are taking it out of the philosophy department and rooting it directly into the hard, unforgiving, heavily scrutinized mathematics of theoretical physics.
Which is a massive paradigm shift. I mean, when people used to talk about living in a simulation, it was always a sort of what-if scenario. It was fun to think about, but you couldn't exactly prove it in a laboratory. You couldn't test it. It was completely untethered from actual science.
Right up until recently. Because according to the text we are diving into today, a groundbreaking discovery by a renowned theoretical physicist has just completely turned the scientific world upside down.
It really has.
Deep inside the mathematical equations that govern our reality, scientists didn't just find, like, a weird quirk or an interesting mathematical anomaly. They found literal, functional computer code.
It's wild.
It's totally wild. So think of this deep dive as taking the proverbial red pill. We are looking strictly at the text and research we have in front of us, and we are going to explore the staggering mechanics of how this is even possible and the terrifying implications it has for your daily existence.
So to even begin to grasp how someone could possibly find computer code woven into the fabric of reality, we first have to understand where they were looking.
Because obviously they aren't just, looking up at the sky.
Exactly. You don't just look through a high-powered telescope and see a giant floating line of C++ or Python code hanging out in the vacuum of space next to Saturn.
Right, which takes us straight from the abstract musings of tech billionaires directly into the incredibly dense chalkboard covering math of string theory. I mean, if you want to find the source code of the universe, you have to look at the universe's ultimate foundational blueprint.
What's fascinating here is that string theory is exactly that blueprint. It is currently our most advanced physics model, and its entire goal is to unite all the disparate rules of the universe into one elegant framework.
Because physics has had a huge problem for a long time.
Oh, for decades, yeah.
Yeah.
Physics has had this massive problem where the math we use to describe the really big stuff, like gravity, planets, and galaxies, it does not play nicely with the math we use to describe the really tiny stuff.
Like atoms and quarks.
Right. Atoms, quarks, quantum mechanics. They seem to operate by completely different rule books. So string theory attempts to bridge that gap. It posits that at the absolute smallest level, like way smaller than quarks, the universe is made of these tiny vibrating strings of energy.
And the vibration is the key part, right?
Yeah, the specific way they vibrate dictates whether they become a photon of light, a particle of gravity, or an electron.
So string theory isn't just another branch of physics. I mean, it is the theoretical engine room of reality. It is the math that attempts to explain how every single particle and every single force in the cosmos basically work together.
Exactly, and the text introduces us to the man who opened the door to that engine room, Dr. Sylvester James Gates.
Okay.
He is a highly respected theoretical physicist at the University of Maryland. We are not talking about, like, a fringe internet theorist making wild claims in a basement here.
No, of course not.
Dr. Gates is right at the center of this incredibly complex, rigorous field. He was deeply studying these sprawling, dense equations of string theory, specifically looking at something called supersymmetry.
And supersymmetry is a mathematical property that tries to balance the equations of the universe, right?
Exactly. It's all about balance in the math.
Okay, let me try to visualize this, just because the math is notoriously difficult. Imagine you are a master mechanic, and you pop open the hood of a vintage, classic muscle car.
I like this analogy.
You know exactly what you were supposed to find based on all the laws of mechanics. You expect to see the standard metal gears, the rubber belts, the heavy steel pistons, the oil pan.
Oh, the usual stuff.
Exactly. You expect natural mechanical components that follow physical laws, but instead of an engine block, you look down and you find a glowing, highly engineered microchip just sitting there, pulsing with perfectly structured digital data.
Wow, yeah.
I mean, it completely shatters the context of what you were looking at.
That is a brilliant way to frame it, because Dr. Gates was looking at the natural world, expecting to find the standard, gears and belts of natural physics, the messy, continuous math of nature.
Right.
But instead, embedded directly inside the equations of our reality, he found a very specific, highly structured type of mathematics known as error-correcting code.
Okay, so here's where it gets really interesting, and I have to push back a little bit here.
Sure.
Because when we say he found error-correcting code, are we talking about a metaphor?
Right.
Like, nature has a way of balancing its equations, and because we live in a digital age, human beings just decided to call it code because it's a convenient analogy.
I see where you're going with this.
I mean, human brains love to see patterns that aren't there, We look at clouds and see faces. So are physicists just looking at complex math and seeing computer code because we are completely obsessed with computers?
That is the exact skepticism you should have. It is called pareidolia, seeing familiar patterns in random noise. But the text is explicit here. This is not a metaphor.
It's not.
No.
Yeah.
It is not just random weird math that loosely resembles human technology if you squint hard enough. Dr. Gates discovered a precise binary block code called the Shannon-Fano code.
Wait, and just so we are completely clear on this, the Shannon-Fano code is a literal piece of human technology.
Yes. It is a specific mathematical algorithm invented by Claude Shannon and Robert Fano in the late 1940s.
The 1940s.
Yeah, the 1940s. It was created at the dawn of the digital age to solve a very real human problem, which is transmitting digital data without it getting corrupted.
Okay.
And today, it is the exact same foundational logic used to make internet browsers run smoothly, search engines pull up results, and complex computer servers communicate without completely crashing.
But how does a human-invented algorithm from the 1940s physically manifest inside the math of a subatomic particle? How does a computer code actually work in the context of physics?
So to understand how it manifests in physics, you first really have to understand how the code works in a normal computer.
Right.
When your computer downloads a file or streams a video, it is receiving millions of binary bits, ones and zeros. But transmission isn't perfect. There is static, there is interference.
Background noise.
Exactly. If a random cosmic ray or a power fluctuation hits your computer's memory, a 1 might accidentally flip to a 0. And if that happens enough times, the video file corrupts or the computer completely crashes.
Because the data just no longer makes logical sense. The computer tries to read the instruction, realizes a piece is missing or flipped, and it panics.
Exactly. So engineers use error-correcting codes like the Shannon-Fano code. Essentially, the code takes chunks of your data, analyzes them, and adds a few extra bits of information, which are called parity bits, that act as a mathematical checksum.
Okay, I follow you.
So before the computer tries to run the data, the code checks the math. If a bit got flipped by accident, the error-correcting code spots the inconsistency, figures out what the bit was supposed to be, and just flips it back.
So it fixes it itself.
Right. It fixes the data instantly, on the fly, before the system even has a chance to crash.
And this exact mechanism, this highly specific binary checking and balancing system, is what Dr. Gates found sitting underneath the mathematical hood of the entire universe.
That is the mind-bending reality of the discovery, yeah. When Dr. Gates mapped out the equations of supersymmetry, he had to translate the complex physics into massive matrices of ones and zeros just to process them.
Okay.
And when he analyzed those matrices, he found the Shannon-Fano code hidden inside them. The fundamental math that balances the particles in our universe uses the exact same block code structure to manage its information.
Wow. That is completely contradictory to everything we think we know about nature. I mean,
Yeah.
you have a highly specific technology developed by humanity in the mid-20th century, specifically engineered to manage digital data over networks.
Right.
And yet there it is, sitting deep inside the foundational mathematics of string theory. It completely blurs the line between physics and information theory.
It doesn't just blur the line. I mean, it implies the universe is functioning exactly like a digital network that is actively prone to data corruption.
So what does this all mean? Because if you find a literal error-correcting code inside the structural fabric of the universe, logic dictates that the universe is attempting to correct an error.
Precisely. The mere presence of a highly structured solution completely guarantees the existence of a problem.
Okay.
If the universe has an active, built-in mechanism dedicated exclusively to fixing data errors, it means the universe is inherently capable of making data errors.
This bridges the mathematical discovery directly into the nuts and bolts of a simulated reality, doesn't it?
Oh, absolutely.
Because the text points out that according to simulation theorists, if our reality is being generated by some incomprehensibly powerful alien computer, it is still fundamentally a computer. And any computer system naturally experiences data glitches and quantum errors.
If we connect this to the bigger picture, think about what a simulation actually is on a mechanical level.
Okay.
It is a massive, ongoing data processing task. If an advanced intelligence is running a simulation of a universe as infinitely complex as ours, with billions of galaxies, trillions of stars, black holes, and the chaotic unpredictability of quantum mechanics, the sheer volume of data being processed every millisecond is just staggering.
It's literally astronomical.
Yes. And in any computational system, data degrades over time. It is a form of digital entropy.
But let me play devil's advocate here for a second.
Go for it.
If an alien civilization is so incomprehensibly advanced that they can simulate an entire universe down to the atomic level, why would they build a computer with hardware limits that cause glitches? Wouldn't their technology be perfect? Like, why would they need human-level error correction?
That is a phenomenal question, and it goes straight to the laws of thermodynamics and computation.
How so?
Well, no matter how advanced a civilization is, their computer still has to exist physically within their base reality.
Oh, right.
And any physical system that processes information, consumes energy, and generates heat. According to the foundational limits of physics, like Landauer's principle, you cannot have infinite processing power. You cannot have infinite precision.
So there has to be a cap.
Exactly. A computer must have boundaries. And because there are boundaries, there will eventually be rounding errors. There will be microscopic glitches when the system tries to calculate something impossibly complex, like the interaction of subatomic particles in a star.
Got it. And if those tiny glitches aren't managed, they compound, like a rounding error here, a flipped bit there, and eventually the physics of the simulation just break down and the entire universe crashes.
Which is exactly why the Shannon-Fano code is there.
Wow.
To stop the simulation of our universe from crashing, the creators would be absolutely forced to build error-correcting codes directly into the source code of spacetime. The universe isn't just passively existing, space is not empty. The fabric of reality is actively managing its own data integrity just to survive.
So essentially, the fabric of space-time is constantly buffering and fixing itself in the background, just so our physical reality doesn't get a cosmic blue screen of death.
That's a great way to put it, yeah.
It is constantly checking its own math, identifying quantum errors, and correcting them in real time.
That is the inescapable conclusion of finding this code in the math. It changes how you view the empty space between objects. Space is busy. It is processing.
Which naturally leads us to the most startling and frankly unsettling conclusions of Dr. Gates's discovery.
Yeah, it gets a bit existential here.
Seriously. Because if the universe is actively managing data to prevent crashes, that implies it is operating under strict hardware and software limitations.
Yes. A computer, no matter how incomprehensibly large, is still a physical object with finite processing power. It can only compute so much data at any given microscopic fraction of a second.
And the text lays this out so clearly. It says if Dr. Gates's discovery is correct, it means our reality has a processing limit, it has a frame rate, and most terrifyingly, a programmer.
This raises an important question for you to consider about your own existence.
Yeah.
What does a processing limit mean for your physical reality? What does it mean for your perception of time? In a video game, the frame rate determines how smoothly the action is rendered on the screen. If the gaming console is struggling to process an explosion or a complex environment, the frame rate drops and the game visually stutters. Time slows down or gets choppy.
So if our reality has a processing limit, it means time and space are not infinitely smooth and continuous.
Exactly.
I mean, it feels smooth to us, but fundamentally it is discrete, it is quantized. Reality is being rendered frame by frame by frame, likely at the Planck timescale, which is the smallest measurable unit of time in physics.
Exactly. So when you swing your arm through the air, you are not actually moving through a continuous infinite space. You are occupying a discrete point in space, the universe updates, and then you occupy the next discrete point.
I am genuinely marveling at the terrifying idea of reality having a frame rate.
It's hard to wrap your head around.
It really is. Because if reality is just a series of static songs moving incredibly fast to create the illusion of smooth motion, just like a movie reel in a theater, what happens between those frames?
That is the million-dollar question.
Like, are we just blinking out of existence billions of times a second while the cosmic computer renders the next moment of time?
Well, when you look closely at quantum mechanics, particles already behave like this. Electrons jump from one energy state to another without ever traveling through the space in between.
Oh, right, a quantum leap.
Exactly, it is called a quantum leap. But, to your point, yes, the concept that our existence is flashing on and off as the universe updates its data state can definitely induce genuine existential dread.
It does. Because it forces you to confront the absolute final piece of this puzzle, which is the concept of the programmer. If there is binary code woven into string theory, and if there are processing limits dictating the flow of time, there has to be a creator of that system. And the text makes it clear we're not talking about a creator in the traditional mystical sense of a deity or a spiritual life force.
No, not at all.
We are talking about a creator in the highly technical, practical sense of a software engineer.
Someone or something wrote this Shannon-Fano code into the string theory equations of our universe.
Yeah.
Whether that programmer is a hyper-advanced alien civilization running an ancestor simulation, or maybe an artificial superintelligence that absorbed its own universe and is now running simulations to solve cosmic problems, the math points to an architect who writes code.
Which poses the ultimate question from the text. Are we just digital avatars in a cosmic video game?
It's a valid question now.
Are we just incredibly complex, self-aware lines of code programmed to firmly believe that we are flesh and blood, walking around inside a hyper-advanced rendering engine?
When theoretical physics begins to look utterly indistinguishable from computer science, the boundary between physical reality and digital simulation completely collapses. We are left looking at a universe that operates not on magic or arbitrary forces, but on information.
Wow. What an absolutely wild journey this text took us on. I mean, we started with the sci-fi musings of tech billionaires, and we tracked that concept straight into the rigorous, high-level theoretical physics of Dr. Sylvester James Gates.
It's an amazing progression.
We looked deep into the mathematical equations of string theory, trying to understand how all the particles and forces in the cosmos work together. And what did we find hiding under the hood? The Shannon-Fano code.
Right there in the math.
A precise binary block code invented in the 1940s, actively working in the background of physics to correct quantum data errors so our universe doesn't completely crash.
It fundamentally reshapes how you have to understand the fabric of space-time. It suggests a universe governed by a processing limit, a distinct frame rate, and an incomprehensibly powerful external computer running the show.
So, the next time your computer browser crashes, or your search engine stutters, or your favorite video game glitches out and freezes, you might want to take a brief moment to appreciate the error-correcting codes keeping your actual physical reality from doing the exact same thing.
That's good advice.
We are all space explorers in this incredibly strange, mathematically complex universe, so as the text reminds us, you have to stay curious.
And you must keep questioning the fundamental nature of the reality you see around you, even the things you can touch.
I do want to leave you with one final provocative thought to mull over as you go about your day.
Okay.
We know now that error-correcting codes exist to stop the universe from glitching and crashing under the weight of its own data. But what if those codes aren't always fast enough?
Oh, that's an interesting thought.
What would an uncorrected glitch in the fabric of space-time actually feel like to you, the observer? Have you ever experienced a sudden, inexplicable feeling of déjà vu where a moment feels perfectly, impossibly repeated?
I think everyone has.
Right. Or have you ever witnessed a bizarre cosmic coincidence that just completely defied all statistical logic? Could that just be the universe's code failing to buffer for a split second, forcing the simulation to reload your immediate reality? Keep that in mind as you navigate your potentially simulated day.